To find the equation of the inverse relation, swap the x and y variables in the original relation. Don't forget that the domain and range are also swapped. Let's have a look at an example. Find the inverse relation of x minus 3 all squared plus y squared equals 4. Let's call that relation number 1. So where we see x, replace it with y, and where we see y, replace it with x. So that's in keeping with the idea that an inverse relation can be found by swapping the x and y coordinates around. And that can be achieved just by swapping the x variables and the y variables around. So this becomes y minus 3 all squared plus x squared equals 4, which is the same as writing it as x squared plus y minus 3 all squared equals 4. So these are the same relation. I've just written it with the x squared first. So if you graph relation number 1 and relation number 2 on the same set of axes, you'll see that relation number 1 and relation number 2 are reflections of each other in the line y equals x. Now relation number 1 is a circle of radius 2, centered on 3, 0. The domain is x is greater than or equal to 1 and less than or equal to 5. The range is y is greater than or equal to -2 and less than or equal to 2. Relation number 2 is a circle also of radius 2, but centered on 0, 3 rather than 3, 0. And its domain is x is greater than or equal to -2 and less than or equal to 2. And the range is y is greater than or equal to 1 and less than or equal to 5. So you can see that the range of the inverse relation is equal to the domain of the original relation, and the domain of the inverse relation is the same as the range of the original relation. So even the domain and range are swapped, and you can see that here.